Today we'll be building package that will convert Roman numerals into numbers. By numbers I mean int types and vice versa. If there is any integer type, it will convert it into Roman numeral string. So we'll do this through test-driven development. So test-driven development is basically software development methodology which focuses on writing tests first and then writing the actual application logic. So I'll start with creating a package folder, and inside that I'll create a Roman TDD, and inside that I'll create a Roman test.go file. And before writing anything else, I'll first go mod initialize the project, maybe, and here I'll initialize the package. So first we'll test a function that will convert an integer to Roman. So I use t.run because the name of the test gives a very clean output as to which exact test has failed. So instead of using t.rrf directly, I use t.run, and inside them let's check if the number 1 converts to the I. And here I'll initialize the actual test function. Okay, so let's try to run the test. So it says undefined Roman. So I'll just create a file. We need to import this package correctly. Okay, it says expected I got an empty string. So we can write just enough code to make it pass. Okay, it passed. So now we can copy this code and write the same test for 2. It says expected to got 1. So what we can do is, so if you see, test-driven development requires a lot of patience, but its outcome is that you get a stable code that you can trust upon. You can change anything in here, and you can be sure that it works fine by running these tests. So now what we can do here is we can extract these values as variables and call the run function in a loop. I will use the fmt.s printf to format the name of the test. And we can remove these lines. Now we can add one more test case. So now to make all these tests pass, we can call a for loop. So to call a for loop, we will need a string builder which will continuously append the strings into the result. Okay, so that the test passed. So we'll add another test case. So instead of always appending this, what we can do is I should have added as it passed. So we can add in one other case. We can also add another statement. Now let's try to refactor this code. Whenever we see multiple if-else statement, it's a good idea to look into converting that into a switch case statement. So I'll just comment these lines and try to convert this into a statement. appears to pass the test. So one error is that instead of checking if it's exactly equal to, what we need to check is if it is greater than or equal to. So one more thing we can do is to instead of using the I variable, we can use the num itself. This loop will run as long as num is greater than 0, and as long as num is greater than equals to 5, it will append 5, and it will just do num minus equals 5. Now it passes. Let's try to test for these functions. This test case is passed. Now let's check for the another test case. What we can do is to add in another switch case statement. So now to refactor, instead of writing these switch case statement, what we can do is create a list of these pairs, and we can loop over that list and do this logic. I'll show you how. Let's see if this refactoring doesn't break our code. So we can just remove these extra lines. Now the test fails. All we need to do is to add just one more case here. I hope this test should pass without any change in the code. Yeah, it passed. Now for the 40, I don't remember the Roman code, but I'll just check in the Google, and we'll add a few more test cases here. For 40, it's XL. Yeah, it failed for the 52L. Yes. So now we can see the pattern. So I can just write many more all these values. 100 is C. Now 400 is CD, and 500 is D. Now 900 is CM, and 1000 is M. And we can add in here more cases. So here I have added some test cases that you can check. So all the test cases pass. Now what we have to do is to create a test for converting Roman numerals to numbers. For that we'll just write a few more tests. So what I'm going to do is to extract these test cases as a global variable and use this into both these tests. So here we have created our test, and for the time being we'll just slice and just test the first test case. Undefined convert to number. Now it says expected 1 or 0. So all the test cases passed. So it failed run again. Now let's try to refactor this code. So the test passed. So now while looping through the Roman string, we also need to check if there is a known symbol on. So for that, what I'm planning to do is to extract the symbols as a global variable and create functions that check is a valid symbol, and then we'll check if one substring is a valid symbol, and we'll manipulate the number accordingly. I'll just show you how. So here we'll define a function is valid symbol, and that can take one or two characters as input. So I'll just use the variative function call. So we will need to access those characters. So I'll use a So before accessing Roman I+1, we would need to ensure that it is not the last element of the string. Then we'll need to create another function that will get the value of a symbol. Although I agree that these two logics are same and could have been consolidated in a single function, but let's just make it work for now. So here we would also need to increment the I. So instead of directly using the indexes, what I do is use the typical for loop. So now we can safely do I++. Let's see if this algorithm works fine or not. There's a huge error. Okay, what I need to do is to check if it is less than -1. My bad. So all these tests passed, right? Let's check if the fifth test also passes. Okay, so here we are only checking the symbols with the two characters. There also may be symbols with just one character, like V, that 5. Now let's see if this works or not. So let us run our test for all the test cases. So all the test cases pass. So we can do refactoring here, but I think this is enough. Thanks for watching.